If you already passed stage 1 and stage 2 of my roadmap, congratulations, you mastered the essentials. You already know that how the LLMs are working under the hood and how you can shape their behavior with great prompting. But to be honest, without the right information, even the smartest LLM models are failing. And this is exactly the next step of LEAP. Take this step with retrieval augmented generation because it turns the LLM models from a smart text generator to a reliable system that you can trust. This is where you drop the hallucination and build factual stability. Forget any scattered blog post in the internet because I'm bringing for you all of the pieces you need for RAG system in production coming from experience-driven engineering techniques. We will break down different topics of RAG pipeline, including effective embedding, different chunking strategies even for multi-content type of the documents, the vector databases, bringing hybrid search and re-ranking with their advantages to improve the performance of your RAG system, and at the end, managing your context window, which is quite challenging in every industrial project. Every chapter of this video is a critical piece of a puzzle. Let's dive in together. Embedding is important in the RAG system because it determines how well your system understands the meaning or capture the semantic meaning of your text. And because it plays the role of capturing the semantic meaning of the text, at the end it also plays the role of relevant documents when they are retrieved and the same role as grounding the LLM's answer. So it's really important to talk about these component of RAG system, and inside of these components there are 4 topics that is quite worthy to discuss. The first one is about dimensionality, then indexing strategies, similarity metrics, and drift. Each of them, they have quite, I would say, content to discuss about it, but in this video I am specifically focusing on dimensionality. The full access of the content cover all of these 4 topics, and the members in my community, they get such access to content. Before going to the topic of the dimensionality, let me at first mention why embedding matter in RAG system. You know that embedding is about vectorization of the text, which means converting the text into digits in dimensions of the vector, and the dimension can be different, and at the end it's about capturing the semantic meaning of the text, so it determines how well a retrieval augmented system performs. If you're coming up with a really good embedding system, at the end you would have accurate retrieval and fewer hallucination and grounded answer. It played a role. I'm not saying it's not the main component of such impact, but for sure it will impact it as one of the components of the RAG system. But if you are coming with the poor embedding, at the end you would not have relevant retrieval, you would have more hallucination, and the users will lose their trust to your system. Well, now let's focus on the dimensionality. What is dimensionality? How many dimensions do you need for your vectorization? And dimensionality actually determines how much semantic information the vector can store in itself. There are variations of the sizes of the vectors. It can come from the very light version of it, which is from 384 to 768. These vectors are lightweight and well suited for small and medium size of the RAG systems. There are more bigger dimensions of 1024 to 1536. They offer richer semantic representation and is mostly used in domains that need more detailed information to be stored. And we have also dimensions with larger sizes of 2048 to 4096 plus. These dimensions and models that cover these dimensions provide very expressive embeddings capturing way detail of the information, but their computational cost would be high. And the question would come that how dimensionality affect the performance. Actually, dimensionality is the balance between nuance and efficiency. When you are coming up with the higher dimensionality embeddings, for sure it captures more semantic detail of the information, but the cost would be high. From the other side, if you are using low dimensionality embeddings, they are cheaper to compute but faster in the performance side. And it would be a question what kind of trade-off makes sense for your system, which makes sense to be confused with such question, but still there are rules of thumb for dimensionality of the embedding when you want to figure out what would be the best dimensionality for your RAG system. Now let's see what are the rule of thumbs. If your RAG system is quiet general, doesn't have any detail, quiet, domain specific, I would say that go with the 768 to 1536 vector sizes for your general RAG system. If your domain is quiet specific, especially technical one, then choose 1024 to 3072. Still, you need to experiment to see which one is better and don't quickly jump up with the really high dimensionality ones. But if your cases they are quite complicated, they include multilingual use cases, then it would be better to go with higher dimensionality because you would like to get the semantic meaning of different information from different languages. RAG system, I already covered the embedding in previous video, but now we're going to talk about the chunking. But what is chunking in RAG system? Chunking literally means that splitting the documents into smaller pieces so that they can be embedded, indexed, and retrieved by your LLM models in your database. But it impacts the efficiency of your RAG system because at the end you see the result in the quality of the retrieval. Well, now the question comes that why chunking matters. The size and boundaries of the chunk that you are designing for sure affect the retrieval quality at the end in your RAG system. If you choose quite large chunking, at the end you would have irrelevant information in your chunk and would have noisy information as well. So when you are just retrieving one big chunk for one question, you can see a lot of irrelevant information is there. And as you are using a large chunk for embedding, then the cost would be also higher in your end. From the other side, when you are choosing small chunking sizes, then the context would be fragmented between different chunks. And at the end, you would have weak grounding. And because when you're asking any question, one or two chunks will be retrieved, you can see that the response to your question is not complete because part of the information can be in other chunks that you already missed. I covered 4 chunking strategies in this video, but the full 15 chunking strategies already published in my public newsletter. Let's go through these 4 chunking strategies together one by one. The first one is about the fixed size chunking. In fixed chunk, you can see that it literally split the document into equal sizes. And because of these equal sizes, it doesn't consider the meaning or structure of the text itself. It's just quite simple and easy to implement. Based on the number of characters or number of the tokens, you can just split the text. It breaks the sentences, paragraphs, and ideas in quiet, unnatural places, and that's why at the end you would have weakened quality in your retrieval and fragmented context between different chunks. But you may face the question that when to use it if it is really losing the semantic and fragment the context between different chunks. Good question. There is still some cases that this type of chunking can be used because it's quite simple This is for the cases that you just quickly want to implement fast processing chunking in your rack system, and it doesn't matter the semantic there. Like for instance, when you're using with sensor data or log files, there is no semantic there, and there is no need even you care about the semantic that side. Well, as I mentioned, fixed size is quite simple one, but more and more advanced approaches came out that we can use them when the semantic coherence is really important in your retrieval system. Let's go through to the next one. The second one is sentence boundary chunking. As the name clearly says, we split the text on natural sentence ending. Either you can use NLP tools or punctuation detection to find out what are the sentences in your text, list them, and then put them all based on the context window of your LLM model, put them on different chunks and literally go with the embedding. As the sentence already captured, then we have the integrity of each sentence, and it would be more coherent and more relevant when you are retrieving in comparison to the fixed one. When it is useful, the sentence bounding chunking is useful for the case of the articles, documentations, report, or any content that the sentence structure carries important meaning. But be careful, because it can happen sometimes the idea of any context is not specifically in one sentence, but it is split. So it can happen still you are missing part of the context, and it depends on your type of the document that which chunking you should choose. This one is specifically for the cases, as I mentioned, that the documents have the sentences that they carry important meaning. And this structure of sentences are in more detail of information to be retrieved. The more advanced version is paragraph based. As the name clearly says, we split the texts using the natural paragraph boundaries. And it comes from the idea that each paragraph preserves a semantic structure. There is no need to use any NLP tools here to detect the paragraphs, because clearly paragraphs are observable in the text that you have. And when to use this type of paragraph-based chunking is when the content that you already have, it's well formatted. The article, blog, any type of documents that you have, the paragraph, each of them intentionally, they have group of related thoughts together. For this case of the document, for sure, better to use paragraph-based one. As I'm saying, it's more advanced than the sentence. That doesn't mean that it works better than sentence one, because for instance, if you wanna really go with the retrieval in detail information, sentence-based has more detail of information. But if you are caring more about the group of thoughts in each paragraph, then paragraph-based would make more sense to use it. And still it can happen that you are reading one document and you can see that the thought is split between multiple paragraphs. Then this case still would miss part of the information. And another level, higher level would come, which is called heading aware chunking. Heading aware chunking is based on the structure of the text that put all the information related one with under a specific heading. So as the name clearly says, it is split the text according to its structure heading, because it comes from the idea that headings usually mark clear topic boundaries and preserves the author's intended hierarchy. So it means that if we have multiple paragraphs, that all of them are related to each other but under a specific heading, then this is the best case we are using this type of the chunking. So when to use it, as it clearly told, documents that are well structured and they heavily rely on section titles to organize the concepts. But still I'm saying if it is more advanced than the previous one, it doesn't mean that you have to for sure go with this one. It depends on really type of the document that you have, and you need to be careful that based on the content you have, which of the chunking strategy makes sense to use it. Well, you already know different chunking strategies, and 4 of them are explained in previous video for you. Let's go through the coding of them together one by one. I prepared a list of the text here in documents array, as you can see, and I will use this text to give it to the fixed chunking strategy and split them into different chunks with the fixed size. I will read that array from documents.py, and for each of the texts in the array, I will call this function of fixed size chunking to split them into different chunks with the size of 200. It is quite simple. From the beginning of the text, which is 0 index, it will go through the text till the end of it, and when it passes from the start with the size of the 200 character, it will literally segment or split the text, and then again the start of the next chunk would be after the end of this splitted text, and one by one it will go through the text till it reach the end, and at the end we have the list of chunks. In the main text, it's quite simple. When we read the documents in the functions here, it will load the documents or files. Each text one by one will be given to the function, and at the end we have list of the chunks. The output will be in the fixed chunking output markdown file that we can see the running of it together. Let me run it. Well, here I have the fixed chunking output. The size of the chunk size, as the output says, it's about 200 character. The total document that we had from the first text of the document array is 360. So it's obvious that if you divide it by 200, 2 chunks would appear at the end. The first chunk is here, and the second chunk is here. The same for other documents, that one by one it will split them into multiple chunking. The point is that here it quickly works. You literally saw that how fast it is running, because it's just going through the list of the characters and split them with the size you mentioned. But the pain point, or the challenging part I would say, is that it literally leaves the chunks quite meaningless. Why? Because here you can see that the first chunk is going till the end, that is not complete sentence, and literally it loses the semantic context of the sentence. Here we have a sentence of provide inside, and the S part of the inside is go to the next chunk till the end of the text, and literally with this splitted type of the chunk we lose semantic. As it is mentioned already, this type of chunking strategy is fast, but it is useful more for the log files, not for the cases that the text and semantic matters to you. It depends on the use case that you are working with. Now let's go to the next type of the chunking strategy that we have, which is called sentence-based chunking strategy. Previous one had the challenge that it was splitting the text in the middle of the sentence and losing the semantic. But now the sentence boundary chunking strategy solves these issues. How is it working? We are reading the same documents that I showed you in document.py, and we split it by using some of the signs to recognize the end of the sentence. For instance, here the dot, exclamation mark, and question mark assume that would be the end of the sentences. There would be a space after these 3 characters, and then we have a capital letter. Then it considers it as a pattern in text that we recognize what is the sentence when it ends, and then using those characters to split the text into different sentences. And at the end we have list of the sentences together in the sentence bond chunking. We are using the text as the input of that documents array that we already mentioned. And here another parameter I gave, the number of sentences that can be added per chunk. Here the parameter value is 2 sentences. And it quite simply, we will give the text at first to tokenize or recognize different sentences is the paragraph. We have list of sentences, and it will start from the beginning of text, go to the end of the sentences, and one by one add them together. But by considering that only 2 sentences per chunk can be joined for each of the chunk, and at the end we have list of the chunks that in the main function, when we call this sentence bonding chunking, we have list of the chunks that each of them they have 2 sentences per chunk. Let me run the code and see how is the output. I have more explanation about this one, but let's at first run it and see the output together. Okay, now we have the output. And here you can see that the chunks are created for each of the documents. They are ending with sentences perfectly. We have the semantic here. That's amazing for the documents. That semantic meaning is important for you. Literally, this approach would be way better than the fixed chunking strategy. The only challenging part here is that the pattern we consider like dot, exclamation mark, or the question mark in the function, sometimes these type of the patterns are not working well. For instance, some of the documents they are using the abbreviation of the specific names, and they have dot, space, a capital letter, again dot, and blah blah. This pattern will continue, and those ones literally think that there is a sentence there and try to split them. So still we will miss part of the context or semantic meaning of the sentences by using these type of the patterns. This is quite a simple pattern that I implemented. You can enrich it by using other Python libraries like NLTK that they try to grasp the meaning of the sentence and avoid those type of mistakes with the specific names of capital letter combination with the dots, and avoid these mistakes. Another point is that here in the chunking strategy of sentence boundary, I put the sentences number 2. But the point is that here you can make it more advanced, and in the chunking maybe no limit for the number of the sentences per chunk, but you will consider the number of the characters can be in one chunk, because at the end after chunking strategy you need to vectorize, and depend on the bonding or embedding sizes of the model you are using, you need to consider the length of the chunk size. For instance, if your embedding model is 1024, you can choose 1024 characters, and you can add chunks dynamically one after the other till you are sure that all of the sentences can be covered inside of 1024 characters. If anyone passed this, just omit it and add it to the next character and add it dynamically. Here I use statistically, but dynamically is more advanced way of it that you can use it. Another chunking strategy that we have, it's about paragraph chunking. So the PT part of this semantic chunking strategy with these sentences is that these sentences all together they have meaning, and when we are using sentence chunking strategy we lose part of the semantic because this sentence is related to the previous sentence, and that's why paragraph chunking strategy came here to help us, that we still keep the semantic complete in one chunk, with assuming that the paragraph is well structured and each paragraph has cohesive meaning by itself. How is it working? Quite simple. It will recognize each of the paragraphs and one paragraph per chunk, put them into one chunk. How is it working? It will use a simple pattern of new line character, one or multiple ones, and use this kind of the pattern for indication of there is a paragraph there, and then use these indicators to split them into different paragraphs. When we have these different paragraphs, then each of them one by one will be given to different chunks, and at the end we can simply run this function of paragraph chunking, one paragraph per chunk, and we would have the output. Let me run this one as well. Perfect, it ran. I have already the outputs in my folder, but it overrided. If you run it yourself as well, the code, you will get the same output. So here for the document, first document, we have 3 chunks, and each of the chunk they cover one paragraph. So you can see literally that there is no split of the sentences, and we keep the semantic meaning of one paragraph in one chunk. In case that the semantic meaning is really important for you, these type of approaches are way better than fixed size or sentence-based approaches. That's the advantage of the paragraph-based approach, but still it can happen that paragraphs together in another level, they are meaningfully related to each other. And that's why other approaches such as head-aware chunking strategy is coming to work. And how is it working? We are using another type of the array in these documents.py. This type of the approach, I have to say, it is useful for the case that the structure of the text is really important. For instance, scientific articles, that they have title level 1, then beneath of it we have titles with level 2, and goes down to any number that the writer desire to have. And the good part of this type of the headed documents is that we can use the same logic and keep the meaning of related paragraphs together. That's the advantage of these approaches if you compare it with paragraph approach. And another advantage is that you keep the structure that writer of the document had in mind, again in the chunking approach. Here in the document, as I mentioned, we have first level title, then second level, here again second level, beneath of it there are 3 levels, and it can go for more. How is it working in this implementation when we are reading this text document? I want to split the document in level 2. So it at first checked that the level of the documents that we put for splitting is between 1 to 6. It's just a sanity check before any code runs. And then it will try to find out from the document different heading patterns with which numbers they are, number of the hashtags that they have. So it try to find out that they are the level 1, 2, 3 to level 6. When all of them are recognized, then they are found inside of the text to find where the indexes or heading position of them inside of the text. And all of the ones that they have only one from the level 1, they are also listed in top level matches. Why this is the case? Because in this function, when I'm splitting in the second level, I'm gonna use the top level first of the chunking, that this second level is related to it or beneath of it in the chunking one, for keeping the structure of the writer inside of the chunks itself. How is it working? It will go through different levels that it recognizes already and check if it is level 2 or not. If it is not level 2, it will go through the beginning of the loop and continue to the next headings or next titles. If it is level 2, perfect, then this is the time that it should split it. It will try to recognize what is the next level. If the next level is again second level, then that's it. It will recognize that this is the section, that all of it should go into one chunk. If not, the next level would be level 3. Still, it will keep it and attach it to the text that we have. And when it recognizes what would be the text of the chunk, it will go to see where is the nearest top level in the level 1 that later attach it to the text itself. So when it really finds the first top level title that is closest to this title of level 2, it will attach it to the text. Here you can see that the top level is recognized, attach it to the text of the chunk, and at the end it will create list of the chunks, and we have head-over chunking approach here. This type of the coding that also I implemented is for the sake that I show you how is the output, but the real chunking is that you should put all of the text in different arrays, and list of the arrays would be your output. This is just for the case that I want to show you how it is working. Now I'm running it to see how is it working. If we go again back, we expect that level 2, what is AI, with the text of it would come in one chunk, but recognize that the first top level related to this one should also be attached here. We keep the structure of the writer in our chunking. Then the next one, again, next chunk would be from here. It will recognize the next title is third level. Again, the next heading is third level. Then it will put all of them in one chunk. And what is the nearest level 1? Again, artificial intelligence. It will attach it to this one to keep the structure of the document. Let's see how is the output. Well, here we have the document and different chunks. You can see in first chunk it put what is AI with second level heading in one chunk, but it attached the artificial intelligence on top of it as well. The same for the next chunk. It put the level 2 key subfields and the next 2 levels in third level, third title in the same chunk, but again chunking includes the heading, title, or level of 1 artificial intelligence into the chunk. That's exactly the approach that we need to keep in mind to keep the structure what the writer had in mind in our different chunkings we create. Perfect. We already covered 4 chunking strategies. The very basic one, fixed one. The second one, sentence. Paragraph based, the third. And fourth, heading aware chunking strategy. All of these codes maybe doesn't look clear to you. All of the codes are included inside of the handbook of stage 3. You can literally use the code there beside of other examples inside of the handbook. And in the previous video, I talked about different chunking strategies, but it was mostly useful for the content that is fully with text. Now this one is more complicated because I'm gonna focus on the contents that are from different data type, not only the text itself in the document. And in your rack system, if you wanna chunk them, it is quite challenging. But going back to the type of multi-content documents, what I mean by that, the real-world documents often have multiple different variation of the data type, like figures, tables, formula, diagram, code block, and any type of the chunking that you are using. If they fail to preserve really valuable information in this type of the elements, literally you miss part of the information. And if you are using any poor type of the chunking, what would be the consequences? For sure, if you have any table, it can happen, it will be splitted into incomplete parts, and you literally lose the semantic relationship between the information inside of the table. It can happen that the figures will be separated from the caption, and you don't know what is the relation between the caption and the figure to get the more meaning behind of the figure. Another part, it can happen, you have a long code blocks, and when you break it with the poor chunking, then part of it would be fragmented codes that are completely unusable. That's why it's essential you are using a proper chunking methods that respect this type of the structure content in your document and keep the semantic relationship between these elements together. In this video, I will just focus on one of the chunking strategy, but my newsletter cover 4 cases. The one here in this video is about layout ever chunking strategy. There is no official name such a thing, but it's mostly inspired from the research. Later I will explain it. As the name literally says, it will focus on the visual structure, not only the text data. It can analyze the columns, header, footer, table, diagrams, if you have captions for your figures, and page regions. The backside of it is vision text models such as the layout LM models, or you can use the OCR models with really accurate information extraction from the visual elements in your document, or you can use the PDF parsers and tools that they preserve the layout. For instance, PDF Plumber, Unstructured.io, and Adobe PDF Extract APIs. The result of such type of the chunking is that it literally respects how the document is visually organized, and it is crucial for the layouts that often have meaningful information and you can encode it easily. You may face the question why such a chunking strategy is there, and you already can use the chunking strategies with the text. It happens that for some use cases, literally this type of chunking strategy worth to try. For instance, if you're working with the scientific paper, they usually have multi-column layouts. If you are working on the finance, the financial reports include the dense tables with huge information inside of it and the footnotes. If you're working with engineering documents, they contain diagrams and schematics. And it can happen even the textbooks that include sidebars, colors, and figure references, that they literally include meaningful information. And if you don't use these multi-content chunking strategies, you would miss out part of the valuable information from your documents. As I mentioned, there is no official definition for layout ever chunking strategy, but it is inspired by the research in the domain of document layout understanding and vision language models. The research at first comes from the layout LM model. This model considers 3 types of the embeddings, one for texting, one for the positional encoding, and one for 2D layout embedding. Later, second version of this came 2 years later, if I remember correctly, and it is using the CNN and ResNet model to extract the visual features based on the pixel. Third version of it came later that considered the vision language model, and the advantage of this is that the structure completely changed. The structure of it completely changed because it is using the vision language models, and it can literally consider both the text and visual elements from the input. I also mentioned that you can try PDF Plumber and PyMu PDF tools, which are really worthy to try it out. Well, during the video, you learned that chunking strategies is not only applicable for the text, but also for the content that has the visual effect as well in the documents. For instance, here in the shared screen PDF file, you can see it has multiple tables. And this type of the visual effects we have in the documents give us the hint that the simple chunking strategies for the text cannot be useful because the structure of the content in these tables and any other visual effect is important to us. That's why we need to think of other approaches that are relevant for the content, multi-content documents. The example that is shared in the document with you is about layout over chunking strategy. There are multiple examples inside of this specific chunking strategy. I'm using only PYMU PDF file in this video, but the handbook of stage 3 has full of the codes itself that you can get the code when you are buying the PDF and run it by yourself, apply it on different documents. This one I'm only using PYMU PDF. This Python library is free. You can easily use it for different PDF files and extract the content and keep the structure of the document very well when you are extracting the text from documents. How is it working? It depends on the type of the coding that you have and the documents you are using. For instance, I'm using simple caption pattern. In this case, it will recognize different patterns that we have usually in documents. The captions usually start with figure, table, chart, diagram, and it considers it as caption. Then, when you are using PYMU PDF Python, it recognizes different blocks inside of your document. You need to extract text from each of the blocks that it recognizes. That's exactly the first function is doing. When it recognizes the block, you can call this function to extract the text out of the boxes. Sometimes can happen that the boxes have the intersection with each other. For instance, here you can see that the first box with the second box would have intersection because this is a table here and other type of the charts. This is useful later. You can use it for recognition of if there is any intersection for the case that maybe you see if there is a table or not. Even some of the documents, they have 2-column text instead of the 1-column. So you can implement some of the functions like this one to recognize if the text inside of the page is with 2-column or 1-column. If it is 1-column, simply it can row by row extract the text. But if it is 2-column, at first it should read one text, 1 column, and then the second column. If it goes row by row, literally all the information of 2 columns will be messed together and you cannot keep the structure of the document and the semantic of document very well. So that's the intention behind this function. You can recognize the tables with this function, and all of those functions will be used that at the end we extract the layout units. How is it working? When you give your PDF file to the Python, it will give you the list of the pages. In the function, there is a loop over the pages. It will recognize the width and height of the page to see how is the size. Then the 80% of top of the 80% will consider as the heading of the page, and the bottom that is less than the 92% will be as a footer. If your page doesn't have any heading or footer, you can literally remove these codes. Then it will try to recognize if there is any table inside of the document or not. If it is, then the bounding boxes out of the table around the table will be given to this parameter table B box. Then at the end we have list of the boxes as I mentioned for each page, and we need to have the list of those boxes all together. When we have list of those boxes for each page. It will go through one box to another one. It will extract the text out of them. When the text inside of each block is recognized and extracted, then the bounding box of it also is saved, and all of them will go to the text block list that we have. From each of these text blocks, we have bounding box of them as well. Here is the bounding boxes that we attached. These bounding boxes will be given to the function of the detect two columns to see, based on the bounding boxes of the texts, if the page is with two columns or one column. That's the usage of this function here, that if it is a page with two columns or not. Then the next part is about checking for different blocks that if there is intersection between them or not. And if it is any intersection of it, then it will give it to function of the tables to see if there is a table there. If there is a table, then another approach of reading the document would come on top. And another part is that checking inside of the text of each of the block to see if they are matching with the pattern of caption or not. So it will recognize that inside of these text blocks we also have the caption or not. Another part is that we have the bounding boxes and coordinations of the different blocks. It will check it with those heading and footer band that we defined to see whether there is a header or footer inside of page or not. So literally we will find out what is the structure of the page after covering all of the text boxes. For the bounding boxes for each of the box that is go through of it, it will also check the vertical center of it. If the vertical center of it is less than the top band, then it will find that there is a header. If it is below the bottom band, then it is a footer. Other than that, the block that we have is just the body of the page that we extracted. So that's the way that it recognizes whether the block is a header, footer, or the body of the page. After it is recognized, the header, footer, body, it will check that how is it with the two column. If it is two column, then it will give the values to the columns of 0 and then 1, 2 values, because later it gonna read it differently. Otherwise there is just one column, and it will attach it to the units that we have. But still our work is not finished. It's just the basic part to see that what is the text of the block that we have for each block, how is the bounding box, how many columns it has, is it header, footer, does it have the table or not, or does it have any caption or not. But the next one is about sorting out all of these units. For instance, if it is the two column page, then it will at first read the first column and then the second column, sort them out, and then read them based on the column itself. Other than that, it's just one column that read the text. That's how it's organizing the text by itself. The other part of the code is about the caption. When it is recognizing that if there is a caption, it assumes that the caption is written under the figure, chart, table, or whatever. That's why it will check what is the previous block box that is recognized, if it is in the same page or not, and if it is not a header or footer, and also the distances between these two blocks of the caption and the previous one is less than 80 pixels. Then it will consider, oh, that's exactly relevant figure chart or anything that is this caption for. Then it will merge the caption with the text of that previous block it recognized, and that's exactly how it will sort out all of the units. If it is a caption, assume that the caption is written in the bottom of the visual effect, it attaches it to the text of it. If there is a 2-column page, it will read the first column and then second column. And that's the way that it is sorting out the content of all of the units together. And there are other type of the cleaning steps like removing repeated headers and footers. These are just extra post-processing cleaning. I would say that there is no need I explain it here for you. And we would have the main function of building the layout aware chunk, that literally it is using the function I explained to you, and when the structure of those units are made, they will be all together into different chunks. Let's actually run it and see how is the output. In the main function, I'm calling these sample tables PDF that I showed you here. I'm curious how the content of these different tables are extracted. Let me run the code. The output of this running will go here to layout aware chunking table output markdown file. Again, this markdown file is just for showing you how the function and the code is working, but for your case you need just put the chunks in the list together to later easily give it as a list to embedding models for vectorization. This is just for the showcase to show you how the chunking is working. Let me open actually the output file. So here, going from the beginning of the page, the first chunk here, if I go back to the document, you can see that we have the first row of the table, column header th 3 times repeated, then we have row header th, and if it was not recognizing as a table, then it would not read it the structure very well. But now you can see that in the output the column header th 3 times is repeated, so it concatenated the context of different bounding boxes inside of the table. The same for the next row of the table and the same for next row of the table. The only mismatching part that I see here is the caption. So here the caption is in top of the visual effect or the table, and because it's not in the bottom of it, then when it goes with the caption recognition, it will attach it to the previous object or box that it recognized. So here you can see that the table is attached to the previous text, or the same here, the table 2, it is useful for this table, but it will attach it to previous one because that's the logic of the code. You can simply just change it and put it as the next object that it will recognize it. That's why intentionally I put it here, to show you that it depends on the type of the documents. You can play around with these settings and the structure of the tables in your own code. Perfect. The structure of the tables are row by row added, and even in the next table the numbers are correctly recognized and in the same order, like banking 2.9 for 4.23. We can see it here for the previous rows. Amazing. Another case is about the other text documents that I have for this PDF file. tourist.pdf. I'm giving it again to the code to see how is it working. The point is that the py.mu.pdf file reader is not working well for this type of the chart. So for tables it worked very well, but not really accurate for this type of the charts or diagrams. Let me run it through this and see how is it working. Simply I will just change the input of the function, put it to risk, and in the output it should go here to risk. I will run the code to see how is the output. I'm more curious about the chart here, that if it can recognize it or not. I can show it here, but you can play it with other type of the documents yourself and see how is it performing. It's still running. Well, now we have the output. It's generated here. I will search this sentence inside of the generated markdown. So this is the text that is extracted from the PDF file, and the previous recognized text is inbound tourist, outbound tourist. Before this one, if I scroll up, I have inbound tourist and outbound tourist. So literally you can see that this chart in the middle is not recognized very well. So this kind of disadvantages also can happen, and you need to see what type of the precision you would love to have when you extract the text to have the best approach when you are extracting the text. Well, that's it, the sample for layout ever chunking strategy for multi-content documents. Again, this code is inside of the handbook. You can get the other codes as well and run it by yourself. The very first question pops up to our mind is that what is exactly vector database? As the name clearly says, it's the type of the database that stores vectors or embeddings. But what is vector? Vector is the numerical representation of different data types that are not already in digits or numbers. For instance, image, text, audio, and video. You can define the dimension of your vector during vectorization process, or you can try a different type of the models with their own variation of dimension setting. You can easily take advantage of this technology and search through huge amount of the data easily, efficiently, and quite fast. And this search is quite semantic. What I mean by that, when you have two vectors that they are lies together or close to each other, it means that the contents are similar or quite similar. But when the vectors in representation are far apart from each other, it means that they have quite different content. And this is huge advantage of enabling your system to go through a huge amount of data and gives you exactly the content that you are looking for or even similar to that. Now the second question is that what's the difference between vector databases and traditional SQL or non-SQL databases? The very first difference goes with the query types that we have. In traditional databases, we are searching through exact match or keywords among the structured data, but that's not the case in vector database. In vector database, you just search any type of the question you have, and it search through data semantically via meaning. It doesn't mean that it should be specifically exact matching or keyword matching. The type of the data in traditional database is quite structured, columns and the keys, but in vector database there is no such structure there. You just transform your unstructured data in format of digits with different dimensions. The indexing is also different. The indexing algorithm for traditional databases or algorithms such as B-tree to help you quickly go through the structure of data such as tree and get the result. But for vector databases, we have the vector space and it applies its own type of the indexing algorithm such as HNSW to help you go faster with the search among huge amount of the data. The use cases of these ones are also different. For instance, the traditional databases are useful for CRUD app or create, read, update, and delete applications. But for vector databases, the application or use case is quite different. You use it in your own retrieval augmented system or recommendations or content knowledge base of your own organization. There are variations of these vector databases in the market. The very famous ones coming from the companies with their own cloud platform, such as Microsoft, Google, and Amazon. The other famous ones are Pinecode, VB8, and Chroma. This hybrid search. Well, you may heard about the topic of vector search. If not, I would encourage you to go to my videos and check vector databases and embedding topics there. In short, I can explain there are some data types of image, text, and video that you can vectorize them using some models into vectors of digits. These vectorization or the vector data help you to search through lots of information just searching semantically. This is exactly the same as search engines that you are using on daily basis. But this type of vector search has its own challenges. It doesn't help you to search with the exact matching, exact phrases, and acronyms. From the other side, we have the topic of keyword search. As the name clearly says, it helps you to search with the keywords you're inserting into the systems, exact matching and exact phrases. But it has its own limitations as well. It doesn't let you to search semantically on the information with similar ideas and different type of wording. Hybrid search exactly is the bridge between these two topics of keyword search and vector search. It takes the advantage of both of them to help you have both lexical type of the search and semantic search. Now you may face the question that how the hybrid search works. Any typical hybrid search pipeline has multiple steps using the same topics I mentioned to you. It can search in parallel semantically and lexically. In case of semantically, it uses vector searches to find the semantic relevant information of your question. From the other side, it can search lexically with the exact matching approaches. At the end, the result of both of these cases can be merged together. You can use at the end any type of sorting techniques to find out what sort of information can at the end serve your user's question. Now this question pops up that we got the point of what is hybrid search, but why it is important and in which cases we should use hybrid search in our RAG system. Very valid question. In case you have medical terminology, legal citation, chemistry formula, internal knowledge bases, or product codes, for sure combination of semantic and lexical search using vector search and keyword search would serve you. It also helps you to improve the accuracy of information retrieval. For instance, if your information include any structured content such as log files, table, config files, or error messages, this combination would matter. It also helps you with reduce of hallucination. What I mean by that, if any keyword search can come to help your vector search, at the end you have better grounding, and better grounding results less hallucination. Also, if you have long documents, then the keyword search can pinpoint where exactly the exact matching and exact keyword places in the document, and at the end you can pop up those specific piece of information for your retrieval. At the end, these are the cases that would help you with better grounding information retrieval. As the name clearly says, it's about sorting and ranking, but ranking of which information? Going back to the topic of RAG system, the performance of RAG system depends on the quality of information you retrieve from your knowledge information. The point is that any type of retrieval information pipeline you can have, vector search, keyword search, or hybrid search, it doesn't matter. Re-ranking is just an intelligent layer on top of them that get the output from these approaches, and at the end sort out, filter out, and find out what is the most accurate grounding and relevant information to your user. And the output of it would be the output to your user. So that's exactly another layer that help you to make grounding and less hallucinated information and support the performance of your RAG system as well. As the name, now the question is that why it is important and why we should re-ranking in our RAG system. Quite valid point. There are some cases that for sure re-ranking should be useful. For instance, if you are using the re-ranking layer on top of your vector search, it can happen the output of vector search is just approximate and it searches based on the nearest neighbor similar to the user input. But it's not as accurate as it should be. And the re-ranking get the output from vector search, try to sort out and find out what is more relevant information, especially if vector search struggles with the acronyms, terminology, and exact matching. It can happen in hybrid search also. It needs kind of balance between vector search and keyword search. When it gets the output from keyword search and vector search, it gets two different signals. And the re-ranking here should be there to sort out what combination of them, what balance between these two approaches can give better result to your user. Part of this setting should be in your hand. You will by experiment define what kind of combination and balance should be there, but indeed it is necessary to prepare better result for your user. And at the end, as I mentioned earlier, when you have more grounding information, you give accurate result to your user and less hallucination. Then the performance of your RAG system in total would increase. Indeed, re-ranking is not required in any type of RAG system, but it is essential in some cases, especially in specific domains such as healthcare, finance, legal, and scientific research that high accuracy is highly required. Then I highly recommend you to use re-ranking in your RAG system. It can happen also after hybrid search. There is a conflict between output of the keyword search and vector search. Then re-ranking should be there as an intelligent layer on top to sort out and find out how to make the balance between the output of these two approaches, especially in case of the conflict. It also can happen that after your retrieval, you would have lots of noises, and re-ranking there can serve you with filtering out the noise and prepare more grounding information for your user. And at the end, in some cases, if you are retrieving lots of information and your documents are big, then re-ranking should be there to filter out and just find the smaller scope of information as the output for your user. Well, now this is the time that we see re-ranking in practice. In this code, I'm gonna show you cross-encoded re-ranking approach. This code is in the handbook. You can get the other codes and skills for other approaches as well inside of the handbook and run it yourself. Let's go through cross-encoder together. We have a list of the text that later we're gonna raise some questions from these documents and see how our retrieval system is behaving. The code is quite simple. It's going through the same implementation that you have in your RAG system. Maybe your setting and approaches would be different. You just normalize the text, tokenize it, make them in different chunks. When you make the chunks, you embed them, and you would have retrieval system, either semantically retrieval or syntactically or even hybrid approach. In my code, I'm using hybrid approach for retrieval. This part is about the implementation of hybrid approach. And we have the cross encoder that is used for re-ranking. That's the main focus of this video. I'm using the MS Macro Mini LM L6V2, which is part of the transformer models. The approach of this cross encoder is quite simple. It will give the list of the query that you gave to retrieval and the retrieve documents that came out of the retrieval system. Because in my retrieval system I'm using the top 8 documents, that's why you see here the 8 retrieved documents with their query will be given to cross encoder. And how is it working? It will just try to calculate the score of similarity, semantic similarity of different retrieved documents with the query itself. That's the logic of the work that it is working. And at the end, in the re-rank with cross encoder that use the functions on top, when we give the query and the documents to re-ranker, at the end we have cross encoder scores. And when we have these cross encoder scores, we will sort them out. And at the end, we would have enriched retrieved documents based on the cross encoder score. And we would get the top K of it. Top K for me is that out of 8 retrieved documents, I will pick the top 4 of them. This function is used in the main function. Grounded generate grounded answer is just putting all of those top 4 re-ranked retrieval document in one text and give it as a output. There are 3 questions that from those documents top I'm asking question. We will see the output together. When we are chunking and indexing using retrieval of hybrid approach, I'm using cross encoder re-ranker, and at the end I'm generating the output by re-ranking function. Let's see how is it. Let's run it together to check the output. It's really interesting. These markdown files, when you are running, you will get the same markdown file output. The markdown file output is just for the sake of showing you how the code is running, how is the logic inside of the code to make sense for you. But again, when you are re-ranking, you just have the list of the retrieved re-ranked chunks that you should put them in the list and give the list to next function, either summarizing or concatenating all of the chunks together, and at the end give it as a result to your user. You don't need to have these markdown files in your output. That's for the sake of showing you how the output is working. The code is still running. Well, it loaded the model from transformer and then used the cross encoder on top of the retrieved documents. The code ran. Let's see the output. I will enlarge the page. You can see how is it working. Going to the top, the very first question we had, how does cross encoder re-ranking improve RAG retrievals? It had top results after using the cross encoder, and the results are here, the top 4 chunks that it retrieved. Here I'm using the hybrid approach with the dense and BM25 for semantic and syntactical similarity. They are using hybrid approach with the score of first stage that you can see here. So the point is that literally I'm showing you here first stage to see how is the score of different chunks when I'm using my hybrid retrieval system. If I was not using the re-ranking, the sort or order of these chunks was based on this first stage score descendingly. But here you can see the very first chunk, the score of it is 81%, and here you can see 85%. It means that this chunk was from retrieval the most relevant to the question, but after passing through the cross encoder, it went to the second, and this chunk became the first. Why? Because the cross encoder score of it got higher than the second one. And let's actually use our knowledge to see which one is actually more important. The question is that how does cross-encoder re-ranking improve RAG retrieval quality? The first retrieved chunk is saying retrieval augmented generation combines retrieval with generation. The retriever fetches external context and the generator answers using that context. This grounding step reduces hallucination and improves trustworthiness. That's quite relevant and answer the question very well. Let's see the second chunk. Cross-encoder re-ranking evaluates query document pairs jointly. The model reads both text together and output a relevant score. This is usually more accurate than independent encoding methods. So it's just saying the advantage of it, but it doesn't say how is it working in detail. And that's for sure the first chunk is more relevant to the second chunk. And in our case, you can see that the cross encoder could find the most relevant chunk and order it correctly. That's amazing, right? Well, the code again is inside of the handbook. You can see the code of other approaches and run it yourself to see how the logic is working. The first question is that what is context window budgeting? Let's just put the budgeting topic aside for a while and consider the topic of context window. Any type of the LLM models that you are working, they have their own features, including context window. It can have different values, for instance, 4K, 32K, 200K, or 1 million token. The number can be different, and it just shows the amount of information that it can handle at once. The number can go bigger and bigger, but it doesn't matter because still it's finite. Still it's like a box, and still it's like a suitcase. Well, actually it's a great analogy. For instance, if you wanna plan any trip and you wanna use your own use case, you cannot put everything inside of your use case. You think about different criteria, what you should pick up, what not, what can be compressed, what should stay outside, and everything that you can plan your trip so that it goes quiet smoothly. And that's the same case for your LLM-based application models as well. Consider the retrieval augmented generation system. There are different cases you need to consider for context limit of your model. For instance, the user query, the output of your retrieved documents, the instruction of your system, even the output of the model itself, and beside of it, you would have some metadata. You need to bring all of them in the limited value of context window of your own LLM model. And that's quite challenging. How you gonna manage it? And where the topic of context window budgeting coming is here. Context window budgeting says what should get into your model, what should stay outside, and how you manage the space for these different cases that I mentioned. It's not about stuffing all of the things together into your LLM model, but it's more about strategically allocating spaces to different cases that at the end you would have perfect, high quality answer out of your system. That's really interesting topic, and for sure it's necessary for any type of the LLM based applications you have. Now the question is that why context window budgeting matters. Well, the point is that it is important because your output of the model, the quality depends on what you feed in. Let me break it down. One scenario is that if you give too much information to your LLM model, then it will end up with confusion. For instance, if you just dump 20 long documents to your LLM model with the hypothesis that if you give more context, you would have better result at the end, that's not the case. The opposite would happen, in fact. The thing is that your model would be overwhelmed with a lot of information, the noises will increase, the relevancy will decrease, and at the end the output of your model would be inaccurate. That's quite classical failure mode in RAG systems. The other scenario is that from the other side, if you just provide too little grounding information for your LLM model, then it would hallucinate. How is it working? When you just provide little information and few documents feed it to your LLM model, it tries to anchor the reasoning, but it would struggle. Then what would happen? The LLM model try to fill the gap, try to guess, and at the end it would come up with the hallucination. And that's exactly where the budgeting can help you to provide just enough context for your LLM model. Another scenario is that when you have more input to your LLM model, then your performance and cost would get worse. When you are using more token, you would use more compute. Using more compute ended up with higher latency, and higher latency would impact your user experience. And budgeting here help you actually to trade off the cost and performance without sacrificing the quality of your answer. And the case is that when you are managing the context very well, in case of the budgeting, there would be enough space for your model to compare the documents, to contrast the viewpoints, and try to resolve any contradiction happening between information, and it performed really well in the tasks such as analysis, research, or decision support systems. The third question is that when to use context window budgeting. Quite interesting question, and there are multiple cases that you need to consider. The first one is that when you have long document of legal contracts, logs, manual transcripts, or paper research. You would naturally exceed the token limits by using these long documents, and that's why you need to use the budgeting techniques to compress the information intelligently that you would use the context limits quite strategically. The second use case is that you have too many retrieved documents, and when such a case is happening, for sure budgeting techniques would help you to see what should be included for the input to your LLM model. From those included ones, how long they should be, whether they should be compressed or trimmed or not. The third case is that when you are using long context models, and you may think by using long context models there would be no need for budgeting, but that's not the case. When you overfill the context limit of such models, then the latency would increase, the cost would skyrocket, and relevancy will drop. And for sure, budgeting still help you to keep the discipline. And the fourth case is that when you have multi-step reasoning, for sure your LLM model needs a space to think, to look back the previous steps, what happened, to reason and generate the output. And that's why you really need the context window budgeting for multi-step reasonings. Well, context budgeting is really important, especially nowadays that the cost matter, the size of the context matter, And you will see literally in industry how this topic is quite challenging. In previous video, you saw the logic of the context window budgeting, and in this example, we go through just simple approach of trimming budgeting. How is it working? We have the list of documents here, which is with the inside of it with the title, the text that has different sections. So here we have 3 documents with the structure that I explained to you. And in the main function, we have list of queries that is relevant to those documents. When we give those queries to our retrieval system, it will come up with the retrieve query. We will give each query with the retrieve documents to our main function that's gonna manage the budget for us. The budget that I consider for this function is that at the end I want only 220 words out of all these retrieved documents because the cost matters to me. So let's see how is it working this function. Inside of this function, we get the list of the retrieved documents for one query and the budget that we define. Inside of the function, it will call another function, which is allocate doc budgets. How is it working? It will go through all of the retrieved documents one by one and see how is the similarity toward this query, and then sort them out. And based on the similarity score that they have, it will distribute these 220 among those retrieved documents. And if there is no any similarity, it will just say 40 minimum words that document can have. And that's how it is allocating the budget of 220 words to different retrieved documents. Then it will go into the function of trim document to budget to manage it based on the budgets that will allocate to different documents. Let's go through this function that I show you how the logic of this one now is working. When we are going through each document one by one, we have a query and the retrieved document itself. In each document, it will split the document into segments and see how is the relevancy score of this segment to the query, and it will attach the score of it to it. I got the minimum segmentation relevancy score of 0.06. If the similarity or relevance score is less than this case, it will filter it out. And at the end, we have the filtered list of the segments that their scores is more than minimum segment score. When they sort it out, maybe it can happen that there is nothing is passing. When there is nothing is passing, it will find out the maximum score, which one is, and consider that a specific segment as the output. And for each of the documents, that's how it will recognize the relevant segments and put them together. We have the original word or the document that was as a parameter given to this function, and we have the dropped segments. And at the end, when I'm running this code, I can see that what was the original words that was given to the function and what is the drop segment. If I run it, you can literally see how is it working. At the end, the output will be saved in the markdown file that I can show you how the logic of trimming is working. And it's quite useful, as I mentioned, as the managing of the budget is important to you. Let's see the output. So that's the output that we have. For the first query, how should we handle webhook signature verification and timestamp drift? We have 3 documents that are retrieved with different scores, which is the relevancy, are sorted out. So the very first document ID 2 has the highest similarity score to the query. Then we have document ID 1 and then the third one. Let's go how the trimming literally is working. The first one is doc ID 2, or you can see it here. For this document, you can see that the original words inside of the document was 66 and it kept all of them because of high relevancy similarity it has to the query, and literally it didn't drop any segment. And all of them are covered here. Kept segment, and then if we go to the next document, which is here, the document ID 1 had original words 113, but just 21 of them is used. That's the allocation budget is happening. You can see literally many of the segments are dropped, which is 4 of them, and at the end we have just 21 words for these specific documents that are here. And the same is happening for the next document retrieve one. The advantage of it is that we just pick the pieces that are important, the segments that are important from each of the retrieved document. The rest is not important for us. In this case, we manage our budget, and literally we have better managing of the budget by reducing the context. You can see literally we had at first 251 as accumulation of 3 top documents, but we at the end ended up with 122 words, which means 51% of the words trimmed away, which were useless. And from those trimmed words, at the end we give it to the summary to concat them and make a smooth context out of those 3 trimmed documents. It is happening the same for the next queries, that you can see the first one again, no drop of segmentation. For the second one, 3 segments is dropped, and for the third document, 4 segment dropped. And again, 56% of the words are trimmed away. For the third question, let's see how many words are trimmed away. 49%. That's great. Imagine you would have less cost and manage the context way better by just removing close to 50% of the words away. The code of this budget trimming is inside of the handbook. You can get the code of the other type of approaches inside of the handbook, run it by yourself. For each of them there is a marked down output that literally show you how the performance, how the logic of the code is working. Well, this is how you piece together a bulletproof production-ready RAG system. Congratulations! All the lessons that you pass through this video, they have a direct chapter in my comprehensive RAG handbook. Keep in mind that all the insights that I shared in my handbook, they are not coming only from the theories, but they have a practical script that you can put your hands on it literally. They are also forged from my real engineering experiences after the failures and production pressure. If you would like to try it by yourself through trial and error, it would be wasted of time and also expensive APIs. You can easily skip this headache and level up yourself in this stage of AI engineering right now. So go over to my website, get the handbook. While you are there, don't forget to join my community at shivatechhub.com. My community has the advantage of getting early updates from me and extra resources. I would love to have you there and be more in direct contact with you. See you in the next stage 4.
Grab the links to our practical handbooks in the description below to catch up fast. And make sure to subscribe to stay ahead.